So again, from our last video, what did you say is that of if f of x it's increasing an interval, what this will how the derivative will be look like? It will be positive. And f of x is decreasing on interval, its derivative will be negative. Here we have an example. So we are given f of x and we want to draw its derivative. Okay, how we can do that? Note, you can see this is just a line function. A line function can be formulated as y is equal to mx plus b, where m is the slope. So, since m is the slope, we know the derivative is also the slope. So the value will be, the derivative will be of this is an m, it's just gonna be a constant function. Okay, of we assume the equation will be mx plus b for this function. Okay, the derivative will be just the slope of that function, which is just a constant. And also you can apply the Bauer rule in here and a constant, the derivative constant, to find only the derivative will be just an m. These are two examples. So at each we are given f of x and we want to find its derivative graphically. So in case of this function, what we have is we want to find again f of prime of x. Let's do that. So based on this rule, what does it say? Let's find first where f of x is increasing and where is f of x is decreasing. So here we have two segments, this segment in here and this segment in here. Here f of x values are increasing and here f of x values are decreasing. And also we notice here the slope is 0, which is the same as saying the derivative here at 0. So what does that will translate to? Let's draw this graph. So let's assume the point is here, this point is in here. Okay, I just shifted the function in here, the x and y axis. So this line here will be here, and since we said this x, this the value of this is 0, the slope, so it will be at this point. So first here f of x is increasing. What does that tell us about the derivative? It means it's positive. Okay, so that will start from here, which is steeper, and this will be less steep, so the value will be less as we go to this point. So it's gonna be positive slope, but it's gonna be less steep as x values increases. That will translate to something like this. And then from here, f of x is decreasing. From here, it says f of prime will be negative. So, and notice this graph is symmetric, so it's gonna be exactly the same thing, but it's moving this way. So again, start as steepest, negative, with steep, and then it's become, it's become, to start as shallow and then started to be more and more and more steep. We'll draw the tangent line with the slope at these points. So this is the graph of prime of x. For this graph, first what we can do is take this point here, maximum and minimum. if we draw the tangent lines for these, slope of these will be 0, which means also its derivative or prime at this point, the f prime here will be 0. So if we translate that into here, this point will be here. And then from this segment here, from this peak to this, from this bottom to this peak, the value it's increasing, okay? But it's at different values. So what we can do is have a point here, and we can see these are symmetric, okay? So from this point, we notice that the slope at this point is the steepest. So this will be the highest point. And at these, we know this is increasing over this interval of f of x, which means the derivative will be a positive. So it's gonna be something like this. Okay, and then from this segment to this segment, this is decreasing. Okay, so what we can do, since it's decreasing over the interval, its prime will be negative, so it will be below the x-axis. And then from here it started to be 0, so we'll go down here again. And then from this point, from here to here, the value, always you read from right to left. Here, this is decreasing, this is negative, so the f prime will be negative, which will translate to something like this. Notice this also again at 0, so the value of f prime will be, this is a peak, slope will be 0, so f prime will be a 0 here. So always use the rules in here when you have a function f of x and you want to find its derivative graphically.